Hello viewers, welcome to the digital class of Udayanath Autonomous College of Science and Technology. So viewers, in our last video we have discussed some of the correction codes of error. So in our today's video we will be learning some more error detection codes, that is longitudinal redundancy check and the expansion of longitudinal redundancy check, that is checksum. So what are the advantages of checksum, what are the disadvantages of checksum will be discussed in today's video. So without wasting much of our time, let's move on to our slide, that is longitudinal redundancy check. So the first mechanism of error detection code is longitudinal redundancy check. So in our previous video we have already discussed what are parity check bit, what are two-dimensional parity check, then we have also discussed cyclic redundancy check. But in today's video we will be describing what is longitudinal redundancy check. So longitudinal redundancy check, or it is also known as LRC, generally applies to a single parity bit per bit stream. That means from the whole bit stream a single parity bit will be applied through LRC. So although simple longitudinal parities only detects error, a combination with additional error control coding such as transverse redundancy check are capable of correcting errors. So whenever we are talking about some longitudinal parities that only detect the error, where a combination of error control coding along with the transverse redundancy check will be able or will have the capability of correcting the errors. So LRC field consists of one byte containing an 8-bit binary value. So whenever we have to implement the mechanism of longitudinal redundancy check, at that time the LRC field consists of 8-bit binary value, which is also termed as your 1 byte. So LRC values are calculated by transmitting devices. So whenever we are implementing data communication between two devices, or the devices are used to transmit the values, at that time LRC values are calculated, which append LRC to messages. That means whenever there is a chance of transmitting the data from one device to another device, at that time the LRC mechanism get added to the messages. So the device at the receiving end recalculates the LRC on receipt of the message and compares the calculated value to the actual value received in the LRC field. So whenever the device at the receiving end receives the message, it recalculates the LRC, that means whatever value has been added through the LRC or longitudinal redundancy check mechanism. So after receiving that, it compares the value and it again recalculates the LRC. It again distinguishes the LRC value from the original value and compares whether the original value has been received or not. It also checks whether the LRC field has any changes or not. So if the values are equal, the transmission was successful. That means at the receiving end, when the original message is derived from the LRC value plus messages, at that time if the values are equal, then it is considered as the successful transmission, and if the values are not equal, this indicates an error. That means whenever we are transmitting any type of message, at that time LRC message is also getting automatically added at the end of messages, and they are being transmitted to the receiver side. So the receiver on receiving the data compares the LRC value along with the original value. So if the original value and LRC value becomes equal, then it is considered as successful transmission, and if the values are not equal, then it indicates that an error has been found. Now we will be moving to some expansion of longitudinal redundancy check. So LRC is generated through the following steps. So these are the steps through which the LRC can be generated. So add all bytes in messages excluding the starting colon and the ending carriage return line feed. So whenever we have to calculate or we have to generate the LRC, at that time we have to add all the bytes of the messages which will exclude the starting colon. That means whenever we have to start a message, we add a colon at the end or at the start of the messages. So at that time we have to eliminate the starting colon and the carriage return at the end of the data, and we have to add all the bytes in the messages. Then the next step is that add this to the 8-bit field and discard the carriage. That means while adding the numbers or adding the bits, whatever carriage will be found, it will be discarded and only the 8-bit field will be considered. That means let us say after adding 2 bits or 2 bit stream, we have got 9 bits of stream. At that time, the extra bit that has been found is considered as carries and it is being discarded, and the remaining 8 bit field is considered as the original message or the message to be transmitted. So, subtract the final field value from FF hexadecimal producing 1's complement. Now, whatever data we have found from the 8 bit field, we have to subtract that value from the final field value, and we have to take or produce 1's complement of the previous value. That means, after discarding the carries, whatever 8 bit field we have found, we have to subtract it from the final field value and we have to produce 1's complement of that value. Now, we have to add 1 producing 2's complement. So, after getting the 1's complement, whatever value we have found, we have to add 1 bit more in order to get the 2's complement. So, in this way we can go through the steps in order to generate the LRC. That means, first of all, we have to add all the bytes of the messages, in which we have to exclude the starting colon along with the carriage return that has been added to the end of the messages. After getting the messages or after getting the addition of all the bytes, we have to discard the carries and we have to get the 8 field messages. Next, we have to subtract the final field value from the 8 bit field which we have collected. Then we have to produce the 1's complement of the value. After getting the final value, we have to add one extra bit, that is plus 1, which will be producing the 2's complement of the value that we have extracted from the following steps. So, in this way we can regenerate or generate the LRC, and we have to follow these steps. So, here you can see that, let us say an example, we have 4 bits of data or 4 bit streams. Here is first bit stream, second, third and fourth. In this case, you can see that, let us take the example here first. The first data stream has been expanded over here, the second data stream has been extended over here, the third has been extended over here, and the fourth one has been extended over here. So, these are the 4 data streams that are needed to be transmitted from source to destination. So, here you can see, as per the parity check bit rule, we have to take the 0 in order to, or even parity bit, that is, if the number of ones is even, then we will consider as 0. So, here you can see there are 4 number of ones in the first row. So, as it is even in number, so the number is 0. Here in the second column there are 2 ones, so it is also even, so 0 is present over here. In the third row, as there are 3 ones, so it is odd number, so if there will be odd number of 1, then it will be considered as 1. Similarly, in fourth, as there is 1, so it is also odd, so we have to give as 1. In the fifth row also there are odd, similarly 1. In sixth we have 1 odd, that is also 1. In the 7th bit we have 3, that is also odd, so 1. In the 8th bit we have 2 ones, that is even number, so we have to consider as 0. So, in this way you can see that whatever value we have collected from this tabular data and whatever value we have gained through the parity checking, that is, if the number of ones in a single row is even, then it will be considered as 0, and the number of ones, if it is odd, then it will be considered as 1. So, in this way we have calculated the parity bits of the whole tabular data. Now, you can see that there is another bit or bit stream which is considered as LRC, which is being attached to the original data, and this is the sender side which will be sent to the receiver side. So, here the LRC is computed at the destination side, but the LRC that is being received is something else. So, you can see that 0100111 is the data that has been received at the destination. So, if the values are different, at that time we will not get the original data, or it is not considered as the successful transmission. So, a successful transmission is considered as a data that is the original data will be equal at both the sender side and the receiver side. So, that is why here you can see that the whole original data is hit by burst error of length 5. That means, here in this data we have a burst error of length 5. So that here we will be knowing that here in this data, whatever data is being sent from the sender side is not equal to the data that has been received at the receiver side. So this is all about the example of longitudinal redundancy check. Now we will be moving to some more examples of longitudinal redundancy check. So in a system environment where a data stream is accepted from a host during host initiated operations, LRC calculations are performed and appended to every received data block. So whenever we are working in a system environment where the data stream is accepted either from the receiver side or by the sender side, so LRC calculations are performed. That means it is automatically calculated, and whatever value has been calculated, it is automatically appended or added to every received data block. That means whatever data block we will be working on will have the original data plus the LRC calculations value. So the resulting blocks are stored in the subsystems. So whatever data we have got from the original data plus LRC, it is the resulting block and it is stored in the subsystems. So as data passes through the subsystem, so LRC calculations are performed. So whenever we are sending any data from one place to another place, at that time LRC calculations are being performed. So if the host requires data later, a data block is sought along with the previously calculated LRC. So whenever the data is found some error, at that time the host or the sender requests the data later, where the data block that is being calculated was seen that whether it has any error previously or not. So it will calculate the previously calculated LRC and it will send the data. The same LRC exclusive or calculations are performed and compared with stored LRC values as data is transferred to the host. So whenever that LRC is being sent, so it is being sent exclusively and calculations are performed and compared with the stored LRC values. That means whatever LRC values are collected, that will be compared and that will be added and it will be performed along with the data that has been transferred from the host. So if the stored value matches the newly calculated values, the data is considered to be valid. That means whatever data was being sent from the sender side and whatever data is received at the receiver side, if the value matches at the sender and the receiver side, at that time the data is considered as a valid data, otherwise it is not considered as a valid data. That means if any bit of stream has been changed from sender side to receiver side, at that time we considered it as a error and the transmission is not at all considered as a successful transmission. So again the data will be retransmitted from the sender side and again it will be checked whether the original data has been received at the receiver side or not. Now we will be taking another example of longitudinal redundancy check. So here you can see that this is the original data. So there are 4 bit streams of data which are written over here. You can see the LRC that has been calculated over here. So you can see that we have even parity check. That means if we have odd number of ones, then we will have 0. If we have even number of 1, that is considered as 0. If we have odd number of 1, that is considered as 1. So in our last 8 bit you can see that as there are even number of 1, so it is 0. Here there is odd number of 1, so it is as 1. Here it is even number of 1, so it is as 0. Here it is having odd number of 1, so it is 1. Here it is even number of 1s, that is 0. So in this way the LRC is calculated by taking the even parity bit mechanism, and here you can see whatever data we have collected to send it from the sender side, so that data is added to LRC and LRC got automatically appended at the end of the message and this message will be sent to the receiver side. So this is all about the process through which the longitudinal redundancy check is calculated. The original data is being attached with the LRC and it is being sent from the sender side to the receiver side. Now we will be moving to the next category, that is checksum. So checksum is the error detection method used by upper layer protocol and is considered to be more reliable than LRC, VRC and CRC. That means checksum is the most powerful error detection mechanism which is actually used when we are sending the data from sender side to the receiver side. So it is being used at the upper layer protocols because the upper layer protocols that are being used at the user end are most prone to error. That's why checksum is mostly used in order to correct or detect any type of error that has been found in upper layer of protocol, and it is obviously more reliable than LRC, VRC and CRC. So this method makes the use of checksum generator on sender side and checksum checker on receiver side. So there are two devices or two mechanisms, checksum generator at the sender side, because at the sending side checksum generator will generate extra code which will be attached to the original message, and similarly the checksum checker is the mechanism which is executed at the receiver side, because the checksum checker will check whether the checksum value that has been generated by the checksum generator is same or not. If it is same, then the data is, or the original data is same, otherwise it has some errors. So at the sender side the data is divided into equal subunit of n bit length by the checksum generator. So whenever we will be considering the data at the sender side, the whole data that we need to send it to the receiver side is actually divided into equal subunit of n bit length by the checksum generator. So this bit is generally of 16 bit length. That means whatever data will be calculated by dividing the subunit will be 16 bit length. So these subunits are then added together using ones complement method. So after getting or after generating the 6 bit length, these bits are added together by taking the help of ones complement method. So this sum is of n bits, the resultant bit is then complemented. That means whatever sum we will be getting, it is of 8 bits or n bits, and the resultant bit that we are going to have to be added to the original message is complemented. That means the zeros bit will be complemented to 1 and the 1 bits will be complemented to 0. So this complemented sum, which is called checksum, is appended to the end of original data unit and then transmitted to the receiver. So after getting the complemented sum, the value is added to the or appended at the end of the original data and is then transmitted to the receiver side. Now you can see the example or the method of implementing the checksum. Here you can see this is the sender side and this is the receiver side. So let's say this is subunit 1, and as we have discussed that the whole data stream will be divided into equal number of n bits. So this is n bit, this is n bit, we have subunit 1, subunit 2, we have added or we have implemented the checksum that is of n bit, and the subunit k is having also n bit. So all the sum of the 8 bits or n bits will be added, and this is called the checksum. The data will be transmitted, the receiver will receive the data will be again divided into number of n bits, as we have equal number of bits, so we will get number of n bits. At that time also the checksum will be calculated. So here you can see after adding all the n bits, we will complement the sum. That means whatever bit we will be getting by adding the n bits will be complemented, and at the receiver side whatever bits we will be receiving, that bits will get complemented, and if the result is 0, then no error is found. That means whatever original value is being transmitted at the sender side, if you are getting the same data, then the result is 0 or it is considered as no error code. So in this way checksum proves the better way as compared to longitudinal redundancy check, cyclic redundancy check and parity check. So now we will be moving to some error detection method in which the data is divided into fixed size frames. So the first one is our sender side or sender send, and the other side is receiver's end. So now we will be moving to the sender send. The sender adds the segment using ones complement arithmetic in order to get the sum. So as we have discussed that whatever bit stream we are having, we will add all the bits, we will take ones complement and we will get the sum. It then complements the sum to get the checksum and sends it along with the data frames. That means whatever original data frames we will be having and whatever value we have got by complementing the sum of all the n bits will be added automatically at the sender's end. Similarly, after getting the data frames where the original message was being added to the checksum, it is being transmitted to the receiver, and at the receiver's end the receiver adds the incoming segments with the checksum using ones complement arithmetic to get the sum and then complements it. So at the receiver end, the vice versa process takes place. That means it will first complement the value, then it will calculate the checksum, and it will then check if the result is 0, then the transmitted or the received frames are accepted, otherwise they are discarded. So after complementing the value, whatever value we have got at the receiver side, it will first check whether the original value is equal to the received value or not. That means if the result is 0, that means we have got the original value, and if the value is something else or the result is something else, that means the received values are not accepted and they are discarded, and the same message or data frames will be transmitted again. So here you can see the example over here. Suppose that the senders want to send 4 frames each of 8 bits. So where the frames are this one. So these are 4 bit streams of 8 bits each, which are needed to be transmitted from the sender side. So here you can see this is frame 1, this is frame 2, this is frame 3, this is frame 4. The sender adds the bit using ones complement arithmetic. While adding 2 numbers using ones complement arithmetic, if there is a carryover, it is then added to the sum. So here you can see this is first frame, this is second frame. So we will be adding it using ones complement method, and if there is a carry, that means here you can see if we are adding the frame 1 with frame 2, we are getting 9 bits of data. So whenever we are getting 9 bits of data, so whatever extra carry we are getting, we will be adding that bit again with the resultant. So after adding it to the value, we are getting this number. So again this number will be added to frame 3. So you can see that frame 3 is here. So frame 3 is added with the previous value. Again, if you are getting more than 8 values or 8 bits, so the extra bit that is considered as carry bit will again be added to the partial sum. So again we will get another result, and whatever result we will be getting, we will be adding with the frame 4. That means if we are using 8 bit of data and we are getting an extra bit, then again that extra bit will be added to the resultant bits or the resultant data. So finally we are getting the original data, that is sum, and then after getting the sum we will complement it. So here you can see whatever data we have got as sum, the checksum will be the complement of that sum. So this is at the sender side, and the same thing will be considered at the receiver's end. So here we will be adding the same number of things by the same mechanism that has been followed at the sender side. Here you can see whatever sum we have got, and we will get the complement of it. So whatever checksum we have received here, then we will add both the numbers. Whatever sum we will get, again we will complement it, and if we are getting the result as 0, that means all the 8 bit streams will be 0. At that time the frame will be accepted, otherwise it will be discarded. So if any of the bit will be 1 at the complement side or at the final value, then the value will be discarded and it will be retransmitted again. So in this way the checksum process is calculated at the sender end and it is being received at the receiver's end. So what are the advantages and disadvantages of checksum? The first or the main advantage of checksum is that the checksum detects all the errors involving an odd number of bits as well as error involving even number of bits. So previously whatever we have discussed in parity bit or cyclic redundancy check, so checksum is better because it actually involves in detecting the error if we have odd number of bits and also if we are having the even number of bits. But previously LRC or CRC, they are considered for a single bit of data, or they will be working either for odd number of bit or either for even number of bit. But checksum can be considered for both odd number of bits as well as even number of bits. Then there is a disadvantage of checksum also. So the main problem is that the error goes undetected if one or more bit of a subunit is damaged and the corresponding bit or bits of a subunit are damaged, and the corresponding bit or bit of opposite value in second subunit are also damaged. This is because the sum of those columns remains unchanged. So the main problem is that whenever the error goes undetected or the checksum is unable to detect any type of error, so at that time one or more bit of the subunit they get damaged and the corresponding bit also get damaged, and consequently all the bits or all the frames that are being added to the next subunits will get the wrong value or the error value, and finally whatever value we will be getting, they will remain as, or they will be considered as damaged data. So in this way checksum will remain unchanged if the sum of these columns remains unchanged. So this is the main disadvantage of checksum. So we have discussed longitudinal redundancy check, how to use or how to implement the longitudinal check, what is checksum, how to implement the checksum, what are the advantages and disadvantages of checksum. We have all discussed in today's video. So if you have any doubt, you can comment me on our YouTube channel. Till then, have a good day. Thank you.